Hello, my name is Graham Knott from the EPFL in Switzerland, and in this video tutorial I'd like to show you how to use the NeuroMorph tools that we've recently made for the Blender software for making measurements of mesh models that in this case are 3D reconstructions of biological features imaged with serial section electron microscopy. Here in the 3D window of Blender we can see the reconstruction of a small segment of a neuron's dendrite. From the shaft of this dendrite we see protrusions that are dendritic spines, and it's onto these that most of the synaptic connections are made in the mammalian brain. And in our analysis of neuronal ultrastructure, we may want to understand the morphology of these structures, and it's this that the NeuroMorph tools allow us to do. So for more information about how we generate these models, I recommend you go to our website where you can actually download some examples and also some example electron microscopy images. So NeuroMorph allows us to measure and manipulate these models, but also see the original images from which they were derived. And here we can add a single image plane at the correct position in the model. And we can also scroll through the images with each one appearing at the correct height. Okay, so let's make a start, and I will begin by showing you how to load the NeuroMorph tools into Blender. Okay, so I've started my Blender software. And here I'm using version 2.7, but it also works in the most recent versions. The first thing to do is to go under the File menu and select the User Preferences, and at the top select the Add-ons tab, and then at the bottom there's an option for installing from File. Then you can find the NeuroMorph files, of which there are 3. Select each of these and then install. Then on the left-hand side you can select the User button and can then choose the 3 scripts, and then you should save the user settings on the bottom button. Then close the window and the 3 tools should be installed. The first is the Import tool that you see in the Properties panel in the Scene Context window, and at the bottom you will see it, and there are various parameters that you can choose. The other 2 tools are on the left-hand side in the 3D window in the Tools panel, and if you click on the plus sign here, or select the T key, you can see them at the bottom of this collection. The first one is the Measurement tool, and I can grab the corner of it and move it up to the top to make it slightly easier. And then is the Image Stack Interaction tool rather, and again move this to the top. So now that you have the 3 tools, I can show you how to import some objects. So in the Import Objects tool, we have a number of options. First of all, there is the Use Remesh function. This adds the remesh modifier, and this reduces the number of vertices in the mesh. You can finalize this remesh or make the function permanent on import by clicking here, but you need to be careful when applying this, as it may change the shape of your model to one that's not very accurate representation of the original feature. There is also a smooth shading option and also a octree depth option that essentially determines how much the number of vertices is reduced by on import. I will show you that a little later. And there is the scale option, which is needed to correctly scale your imported objects. Now if you've used software in which the size of the objects has already been determined, like for example models that come from Track EM2 in Fiji, then you should leave this at the default setting of 1. Which means that one Blender unit is 1 micron. However, if you're importing from software like Elastic, which doesn't care how big the pixels are, then you need to add a value here. Now the objects that I'll import are from images with a pixel size of 0.01166 microns, so that's the value I add in here. Then we can click on the Import button and select the object file from the correct directory. And once we click on Import, we may have to wait a few seconds for the process to occur. So here is the piece of dendrite from earlier, and over on the right is the modifier with the remesh parameters. We can explore how these alter its shape. Changing the octree depth down to 5, for example, simplifies the mesh, but you see that the shape changes a little, and at a depth of 7 it seems that it's a pretty good representation, but this we can check on later. I can apply the modifier here, but you need to take care as this is not reversible. Okay, to show you how to measure things, I've opened the neurites.blend sample file that we supply for download on the website. In it there are a number of objects. You can see here in the outliner window There are some dendrites, synapses and some axons, and I'll explain the nomenclature that we use later on in the video. The first thing to look at in the measurement tool is the renaming function. There are a number of preset options, but what I'll do is select Other and then type in a new name in the box below. Here I'll call this Dendrite 5, then click Update Object Name, and in the outliner box the name is changed. This naming of objects is of course very important to ensure that the data is clearly in order once we export it. Okay, so I'll just change the dendrite name back, and we'll start by measuring the volume and surface area of one of the spines over here. We'll choose this one just here. First of all, go to the Edit mode by clicking the Tab key, and you see the vertices and edges. I can select the vertices that represent the spine by holding the Control key down and drawing around it. Make sure that the button here is actually unclicked so that all the vertices are selected, even the ones that are hidden in behind. I'll then choose the name of this part of the object that I'm going to measure, and as it's the first spine I will select 1 and also complete as it's not a partial object. And this information is important to have in the final data file. Now I can select the surface area or volume functions, or both, and in a few seconds the calculation is made and this will create objects of the region selected. I can see these by going to the Object mode, and then in the outline under Dendrite 1, the new objects are Spine 01 Surf and Spine 01 Volume. In the outline I can make them visible, and by going to the Context buttons and selecting the Object tab, I'm then able to find the data. I can see its name, its volume and its surface area. Looking at the information of the Spine 1 Surf object, you will see that it does not have a volume as it's an open-ended mesh, as you can see as I just turn it around here and just make it visible. That's the surface area and volume, and now I'll show you how to make some length measurements. First of all, I'll hide these new spine objects and reshow the dendrite. And to measure its length, I then need to go into Edit mode again, then select a vertex, and in the measurement tool panel input that point into this window by clicking on Add Point, and then choose another vertex at the other end of the dendrite and again add that point. You'll notice then that I have two options, and I'll select the first option, which is multi-segment distance. This then draws a line between the 2 points, and this is again an object to be found in the outliner under Dendrite 1 and with the suffix ms. And again I can find the details of this line under the Geometry Properties panel in the Object tab and can read the length. If I go back into the Edit mode and this time select the shortest distance, it will put another line object in the outliner, but this is a line drawn along the surface of the mesh between the 2 points. And the details are here again in the Geometry Properties. And you'll see there's a difference between the two lines, and it's of course up to the user to determine which line best represents the measurements that they require. Once all the measurements are made and you'd like to output the data, there are two options. The first is Export Measurements, that allows you to output all the measurements in one single file. And the second is Export Selected. That means you can just have the data from a few objects. This is useful if you've made some corrections or just need to check on a few objects and not the entire collection. To use this, you just need to select the objects you need and click on the Export Selected button. Now to explain the Image Stack Interactions tool. This quite simply allows you to see the images from which the objects were made. And the main use of this is to check the accuracy of the models, or how well they represent the biological structure in the images. The first part of the tool shows the image stack dimensions. In other words, the X, Y and the Z size of the image stack in microns, and in this case it was 3.5 in the X and Y and 2 in the Z. The box below then shows where to find the images, and we can display these images in the model by changing back into the Edit mode, selecting a vertex, for example here, and clicking on the Show Image at Vertex button like so, and immediately an image plane appears in that vertex. By then selecting that image, you can see the orange blocks around it, and then clicking on the Scroll Through Image Stack, you can see all the images in the stack at their correct positions in the model. If you're checking for the accuracy of the reconstruction with the images, it then may be helpful to make the object slightly transparent, and we can alter the alpha value, and this helps to see the object in images at the same time. Another feature in this Image Interactions tool is a function for using the stack of images as maps for finding objects. So here I can see the object, this dendrite in the image plane, but of course there are other features. To find out if any of these have been reconstructed, for example, the dendrite down here, I go to the Retrieve Object from Image part of the tool and click the Display Grid button. This brings up a grid on top of my image. I can then select a vertex in the object that I would like to find, and then I can click on Display Object at Selected Vertex, and this will unhide the one at this position. If none exist here, then nothing will be shown. This feature allows the user to quickly search a large collection of objects in a single image volume to see which features may or may not have been reconstructed. The final function in this tool is the Show Names option, and this, by clicking on the button, shows the names of the objects that are displayed at the time in this 3D window. This helps the user to identify objects without having to scroll through the outliner. So that's about it for this tutorial of the NeuroMorph tools. If you have any further questions, please get in touch via the website, or have a look at the wiki and other documentation that we have online. I hope it's been useful, and many thanks for watching.